Welcome back, guys. Let's start with one sample test. In other words, univariable hypothesis testing. Here in this class, we only cover one sample t-test for the mean of the population. In one sample t-test, we test a hypothesis regarding the mean of a given variable in the population. In other words, mu. We need the following steps in order to perform a one sample t-test. First, of course, as always, we need to specify H null and H1. H null in this case is mu equal to the number m. H1 can be mu not equal to m, or can be also in the form of mu bigger than m or mu less than. Then we set our p-value, which is usually 5% or less, and remember that this is the probability of making type 1 error. Then we calculate the t statistic, which is nothing but x bar minus m divided by s divided by square root of n, where x bar is the mean of the sample, m is the assumed value of mu, s is the standard deviation of the sample, n is the size of the sample. Then we find the corresponding p-value. Then based on the p-value, we either reject or not reject the null hypothesis. In other words, if p-value was less than 5%, we reject the null hypothesis. Otherwise, we cannot reject the null hypothesis. In R, we use the function t.test. Here we use our variable on which we have collected data from a sample. In alternative, we can use one of the three choices. Here mu is equal to m is the value which we have assumed for the population. In one sample t-test, since we are dealing with one variable, it goes under the univariate inferential analysis technique. In alternative hypothesis, mu is not equal to m is called two-sided alternative. Mu bigger than m or mu less than m are called one-sided alternative. In R, as always, I start with specifying my working directory, like my data set. Then there is a question. I want to test a hypothesis regarding the mean of the employees' working hours. So guys, here it's the mean of all employees' working hours. Then I collected data from 30 employees whom I have selected random. Right now I have a sample of 30 employees. Based on the data from these 30 employees, I want to test a hypothesis regarding the mean of working hours for all employees of this company. Always I have to write the null hypothesis first, then the alternative hypothesis. The null hypothesis is the mean of the employees' working hours is 8 hours. Alternative hypothesis, we assume that it's not equal to 8 hours. Then we go for computing the t statistics and p-value, and for that I use this function t.test the $ working hours. Alternative is equal to c two-sided because we said that mu is not equal to 8 hours, that means it could be less than 8 hours or could be bigger than 8 hours. Mu is equal to 8. Run this function. It's one sample t-test. The t statistic is 2.1. Value is 0.04. Guys, before going to the interpretation, look here. Alternative hypothesis, true mean is not equal to 8 hours. This is what we have assumed here as well. True mean of working hours for all employees of the company is not 8 hours. In addition to that, 95% confidence interval is being calculated here. P-value is 0.04, less than 0.05. Then we reject the null hypothesis. When we interpret the result, it means we reject the null hypothesis. Therefore, the mean of working hours of all employees in the company is not equal to 8 hours. Let's see another case, the one-sided alternative. Here we continue to keep our null hypothesis that the mean all employees working hours is 8 hours. So that is mu is equal to 8 hours. The alternative hypothesis this time is that the mean of all employees working hours is less. That is, mu is less than 8 hours. Compute the t statistic and p-value together here. The difference here is that t $ working hours alternative is equal to less this time. Because mu is less than 8 hours, that's the alternative. Mu is equal to 8, remaining the same. So we're done. And now look here, one sample t-test again. The t statistic is 2.13, but the p-value is 0.9. And the alternative hypothesis is that the true mean is less than 8 hours. Now you see, guys, that the p-value is 0.97, which is much larger than 0.05. Hence, we fail to reject the null hypothesis. Remember, guys, failing to reject the null hypothesis is not the same as accepting the null hypothesis. Let's consider another case where I continue to have my null hypothesis as it was, like mu is equal to 8 hours. This time I choose the alternative, which says that the mean of all employees working hours is bigger than 8 hours. It's again one-sided alternative. The only difference here is that I changed the alternative to greater. Let me run this. We see that the p-value is 0.02, which is less than 0.05. Hence, we reject the null hypothesis.